All right, so besides electron configuration, there is another way to describe how the electrons are moving in the quantum atomic model, and we call this using an orbital model. So you notice that in the orbital model, you're often given a series of boxes that look like this. And within each box, you can fit 2 electrons. And I want you to notice that next to all the boxes, there's there are things that we described before, right? So for example, 1s, remember the 1 represents the first energy level or ring. And then the s describes the shape or the orbital that the electron is moving in, right? So if I had oxygen, which has 8 electrons, how would I describe how the electrons are moving in the orbital model? Well, there's 2 basic rules when we're drawing this, right? So one is called the Aufbau principle, and this basically says that electrons occupy the lowest energy orbital first. So I'm going to start from the bottom and work my way up. That's basically what the Aufbau principle says. Secondly, Hund's rule says electrons want to be as far apart as each other, so they're going to occupy their own space or orbital first before they double up, right? So it's very different from what it says here, but in my simplistic version or description, right, if you think of electrons, they're negative, right? So they want to stay as far away from each other as possible. So if I have 1, 2, 3, 4 electrons here, and there's 3 p-shaped spaces for them, I'm just going to draw it over. So let's say there's one here, and one like this, and one like this. It basically means that each electron, 1, 2, 3, the first 3 electrons are going to get their own space first, and then that 4th electron will double up here, right? It's kind of like all the electrons want their own room before they pair up. And it makes sense. It's nice to have your own room, right? So knowing these 2 rules, we can start drawing the electrons for oxygen using this method as well. So I'm going to draw it in pink. Why not? Or purple. Okay. So here we have 8 electrons, right? So the first electron is going to go here, and I'm going to draw it kind of like in a half arrow pointing up, right? Because electrons also move in the opposite direction from each other, trying to avoid each other as much as possible. So to show that, we kind of draw them as opposing arrows like this. So before I can move on to the second energy level, I have to fill this up. Unfortunately, there's only one room, so our second electron will have to go here. Right, so this is the same thing as us writing the electron configuration of 1s2, right? But oxygen has 8 electrons, so I need to fit 6 more. So now that I filled up the first ring or the first orbital, I can move up to the second energy level, right? So here there's only one room as well. So my next 2 electrons, 1 electron here, second electron here, right? So electrons 3 and 4 will be in the second ring, moving in an S shape, and there's 2 of them, right? This is the same thing as writing second ring, they're moving in an S shape. I have 2 electrons. Okay, so oxygen is 8, so I have to draw 4 more. So here in this, we're still in the second energy level, but this time they're moving in the P shapes. So I have 4 more electrons to draw. So here, I'm going to have 1 electron, 2 electron, 3 electrons, so they each want their own room first, And then that last 8th electron will be here, moving in the opposite direction, right? So this is the same thing as writing 2p4. Right? The usefulness of this orbital model is that you can see how the electrons are moving within each shape or orbital, right? So I have this, there are 2 in this first P-shaped movement, and then I have 1 occupying this P-shaped and 1 occupying this P-shape, right? Within the second ring. So let's try another one and see if you can do one on your own. Okay, so this time I have carbon, which has 6 electrons. So following the same rules as before, I'm starting at the lowest energy level. I have to draw 6 electrons total. So I have 1, 2 electrons. Electrons 3 and 4 are going to be in the next one. So electrons 3 and 4. Electrons 5 and 6 are going to be in the second ring, moving in the P shape. So electron 5, electron 6. All right, so this would be my orbital model. And if I were to draw the electron configuration in the first energy level, it's moving in an S shape. I have 2 electrons, so each denoted by the half arrow, one going up, one going down. Then in the second ring, S again, it's moving in this shape, and I have 2 electrons. Sorry, the color is a little bit off. Also in the second ring, I'm going to have 2 more electrons moving in the P shape. There's 1, and there's 2. Right, so that would be our orbital model for carbon. This one right here is the orbital model. This is the electron configuration, just to clarify. All right, so at this point, you should be able to do some practice problems, or at least try them on your own. I'm going to link a reading after this link to the practice and the answer key in case you want to read more in detail about the quantum atomic model and how we use electron configuration to understand how these electrons move.